Glass dish baking temperature. Generally, I have heard that most recipes are designed for baking in metal dishes. I have also heard that glass will get hotter than metal, and thus I should cook it at a lower temperature for longer. Does anyone know whether these statements are true? Am I going to burn the edges if I leave it at the same temperature? What is the truth behind this?
First, the short answer: there's a lot of erroneous information circulating concerning glass bakeware, and very few reliable sources or repeatable experiments seem to be cited. In general, I'd say that the variance among different metal pans of different materials, colors, thicknesses, and coatings will have more significant effects than the difference between glass and metal. So, if you're someone who worries a lot about pan color or thickness and adjusts your oven up or down by a few degrees for it already, then yes, this may be a concern. If you're someone who just assumes all metal baking pans are equivalent anyway, glass is not going to behave much differently. I'd just say monitor your food when trying a new pan, dish, and adjust your time and temperature accordingly. Now, the long answer: part of the problem with comparing glass and metal is that there are so many differences. Metal pans conduct heat faster than glass, which can change both how evenly the heat gets distributed throughout the pan and how fast things cook. But this is mostly relevant when the pan is changing temperature, as when first put in the oven, or heated unevenly. Metal pans can vary in color. Darker pans will cook faster, while lighter or more reflective ones will cook more slowly. Glass is generally transparent, which decreases some types of radiative heat from the pan color, but it also allows infrared light to pass through, which increases radiative heat. Metal pans are usually quite thin compared to glass. Glass therefore heats up and cools down more slowly, so it will be less responsive to changes in baking temperatures. On the other hand, metal pans can also vary significantly in thickness, too. Each of these factors may be more or less relevant depending on your specific baking situation and recipe. For example, if we take the last consideration from the list, if you're cooking something for a relatively short time, glass dishes may spend most of the baking time just warming up, which will affect browning and doneness on elements in contact with the pan. But if you're baking a dish for a long time, this factor is less relevant, and the extra heat which is transmitted through the clear glass may actually cause food to cook faster. There's a common rule of thumb passed along in many cooking sources that one should decrease the oven temperature by 25 F when using a glass baking dish, and perhaps decrease cooking time as well. Other sources agree with the 25 F decrease, but recommend that cooking time will be increased. But I've seen no reliable source justifying when this is necessary or what exactly we are comparing the glass dish with. If we're comparing glass to its closer cousin, a ceramic casserole dish, then yes, in many cases a glass dish may cook slightly faster due to the extra heat transmitted through the clear glass. But it's much more complicated for comparisons to metal. Harold McGee in On Food and Cooking seems at one point to lump glass together with light-colored dull metal pans in terms of overall baking properties, pointing out that both will transmit heat better than shiny metal pans and thus will cook about 20% faster. But dark-colored or black pans will increase browning and cooking even more. I recall seeing a Cook's Illustrated test some time ago that basically claimed the oven temperature reduction for glass was generally unnecessary, but I don't recall the details, and can't find the reference now. In terms of actual empirical data, well, there's this source, see link. 1. On browning, which baked dough for 15 minutes in 4 dishes of the same size but different colors and materials. Glass here performed slower than a black pan or thin, shiny aluminum, but faster than white ceramic. But we can draw few conclusions from such a limited test, since, as I pointed out above, glass dishes take longer to heat up and would likely have performed differently in a longer bake. All of that said, I would offer a few general guidelines. If baking for a short time, say, less than 20 to 30 minutes, the lag time in glass warming up will be significant. Cooking may be somewhat slower for food in contact with the glass surface compared to a metal pan. In a hot oven, it may be useful to lower the oven temperature somewhat and cook longer to allow the food in contact with the glass to catch up with the top of the food, which might otherwise brown faster. When baking for longer times, glass will cook and brown somewhat faster than shiny metal pans, about as fast as dull, light metal, but not as fast as dark metal pans. In that case, you may want to make small adjustments in the same way as you might for different colored metal baking pans. If baking a casserole or similar wet dish and using glass instead of opaque ceramic, it may cook and brown somewhat faster due to heat transmitted through the clear dish. Glass will generally retain more heat when removed from the oven than metal pans, so baked goods or other food left in the glass dish will continue to cook somewhat longer. In some circumstances, this may justify removing the dish from the oven when slightly underdone or else removing the contents, particularly baked goods, from the pan earlier. I don't think there's any truth to the general statement that glass always cooks faster. Lowering the oven temperature slightly may be a good idea if you are concerned about the top surface browning before the bottom in a particular recipe, but glass is not a unique material to do that for. Overall, I'd recommend just using other doneness indicators, internal temperature, browning, texture, firmness, etc. to determine when your food is done. The one nice thing about glass baking dishes is that you can view the food from many more angles, which can often give you information about how fast the dish is cooking on the bottom as well as the top, and you can adjust oven temperature as needed to try to even things out.